What is fog computing? To understand fog computing, we first need to understand cloud computing. So let's see. Internet of Things or IoT is a buzzword in today's world. IoT is basically a network of physical devices that can connect to the internet and share and receive data. This ability to communicate information turns the objects into smart objects. In IoT, sensor nodes collect data which are processed to take necessary action. This is where cloud computing comes in. A cloud consists of remote servers that can host applications. For IoT, a cloud can provide various types of services such as analyze, control, monitor, management, etc. But there are several limitations of cloud computing. Due to the physical distance from end device to cloud, applications that require real-time interactions cannot be served from cloud. Besides, because of the huge number of IoT devices, network bandwidth consumption would be high. Therefore, a new computing paradigm, fog computing, has been proposed as a complement to the cloud solution. In fog computing, similar services of a cloud are provided from a local platform. That is, fog computing brings the cloud services close to the user. So now, the data transfer time and the amount of network transmission are greatly reduced. Fog computing has a hierarchical architecture, which consists of three layers. First, at the bottom is the edge layer. This is the layer closest to the end user and physical environment. It consists of various IoT devices such as sensors, actuators, Arduino, etc. Fog layer. This layer is located on the edge of the network. Fog computing layer is composed of a large number of fog nodes. It includes gateways, access points, routers, switches, etc. And at the top is the cloud layer. The cloud computing layer consists of multiple high-performance servers and storage devices. It has powerful computing and storage capabilities. Fog computing is not an alternative to cloud, rather it complements the cloud. Fog computing architecture adds an extra resources layer between end devices and cloud to meet various challenges of the cloud. Fog computing bridges the edge users and cloud. Fog nodes connect with end devices and users mainly by wireless connection mode such as Bluetooth, Wi-Fi, 4G, 5G, LoRaWAN, etc. On the other hand, fog nodes are connected with cloud by internet to make full use of rich computing and storage resources of the cloud. Fog nodes process and store data generated by sensors and edge devices. Then the remaining valuable data is transferred to the cloud server for storage or next processing. Now, let's look at the difference between cloud computing and fog computing. The cloud is a centralized model, whereas the fog is a distributed model. Deployment cost of a cloud data center is high, while for fog it is low. The cloud has a high latency and the fog has a low latency. The cloud servers are need to be maintained by technical experts, and the fog nodes can operate with no or little human intervention. Now, let's see the benefits of fog computing. First, low latency and real-time interactions. Fog nodes at the network edge process and store data by edge devices in local network. It provides fast, high-quality localized services. Therefore, it enables low latency and meets the demand of real-time interactions. Lower bandwidth. It is inefficient and not necessary to send all the data to cloud for processing and storing. In fog computing, some decisions are made locally without having data to be transmitted to cloud. In this way, fog computing model saves the bandwidth effectively. Enhanced security. Fog computing hosts services closer to end users, so most of the data is not sent outside the local network. Thus, fog has particular advantages in data security and privacy protection. High reliability. Cloud computing is unreliable because connection interruption can occur. such hazard is almost impossible with fog computing because of the close proximity and decentralized control. So that's it for fog computing.